This video lecture is for MSc Computer Science second semester, paper 4, Principles of Compiler Design. It will be covering Unit 1, Introduction to Compilers. Myself, Mrs. K. Manju, Assistant Professor, St. Thomas College, Bhilai. So, we'll be seeing what all topics we'll be covering in the first unit, Introduction to Compilers. We'll be dealing with 4 main topics, that is overview, structure, implementation, and programming languages. First, we are going to see what is a compiler. Now, what is a compiler? Compiler is a software which converts a program which is written in high-level language, what we call it as source language, to a low-level language. Again, what is a low-level language? We call it as an object code or machine code or target code. So, in this diagram, we can see the high-level language is converted by the compiler to the low-level language by compilation process, by compiling the error. Now we'll be seeing how the language processor works. The language processor will be converting your high-level language to absolute machine code. We'll be seeing what are the processes are going to take place in this conversion. The high-level language is first fed to the preprocessor. The preprocessor will give the pure high-level language to the compiler. The compiler in turn gives assembly language to the assembler. And the assembler gives the relocatable machine code to the loader or the linker. And in the final term, we'll be getting absolute machine code from the loader or the linker. We all know what is a high-level language. So, high-level language includes various hash signs, what we call as hashtags, hash include, hash define, directives, what we call as a preprocessor directives. They direct the preprocessor about what to do. So the preprocessor will do what? It will remove all the hash include directives by including the files called file inclusions and all the hash define directives by using macro expansion. It performs file inclusion, augmentation, and macro processing. In the next phase, we'll be getting assembly language from the compiler. Now, what is assembly language? It is neither in the binary form nor in the high-level form. It is an intermediary state. That is, it is the combination of machine instructions and some other useful data needed for the execution. The assembly language is then fed to the assembler. Assembler, they are not universal since for each platform we'll be having one assembler. Like we can say we are having a manual. If we are having a manual for operating one machine, we can't use that particular manual for operating another machine. So, we'll be having an assembler for every platform. It will be different for every platform. It translates assembly language into machine code. Next, we are having the interpreter. Now, what is the interpreter? Interpreter converts the high-level language into low-level language, just like the compiler, but it will be the compiler converts the high-level language into machine language in one go, but the interpreter will read line by line and convert it into the machine language. The next is relocatable machine code. Relocatable machine code means it can be loaded at any point and it can be run. It means it can be in any address position, means it allows the program to move in the memory to various positions. So it allows what? It allows program movement. Okay. Then we are having the loader and the linker. Loader and the linker will be having this relocatable machine code. It will be converting this into an absolute machine code. That is, the linker loads variety of the object files into a single file and make it executable. And the loader loads it in the memory and executes it. Now we will be going through the various phases of the compiler. Now in this diagram we can see the various phases of the compiler. That is, the high-level language is fed to the lexical analyzer and then to syntax analyzer, then comes the semantic analyzer, then the intermediate code generator, code optimizer, and target code generation. Along with this, we are having the symbol table and error handler. handling. So we'll be looking into it one by one. So first is we are looking into lexical analyzer. Lexical analyzer, it is also known as scanner, or it is used for scanning. The first job of the compiler is to group sequence of characters into tokens. Tokens means it should be meaningful. The characters or the character streams are grouped into streams of tokens called lexemes, and they are mapped into tokens. The analyzer will access symbol tables to store and retrieve information. The retrieve information source language, that is the source language concept. For example, we can see we are having equation like A equal to B plus C. Here A is the identifier, B is again identifier, and C is also identifier. And the equal to and plus, they are the operators. Same way in the example, position is equal to ID asterisk rate plus 16. So here we are having the two operators. We are having the three operators, sorry, that is the equal to, multiplication sign and addition, asterisk and plus. Position, ID and 60. These three are the identifiers. The next comes the syntax analyzer. Now, syntax analyzer means after lexical analysis, parser takes over for checking the grammar sequence of the grammars, or checking the grammar of sequence of tokens according to the rules defined by the syntax of the programming language or the source language. So, in this phase, in the syntax analyzer, it is converted into parse tree, or here comes the role of the parser. It will create a parse tree. We can see a parse tree is formed here, that is having an assignment statement, identifier, position, expression is there, and expression is divided then again into identifier and expression to identifier and read plus 60. So we are having that example, position is equals to ID asterisk read plus 60. Then comes the semantic analyzer. The compiler now performs additional checks such as determining type of expressions and checking that all the statements are correct within the typing rules. So it will be seen after formation of the parse tree that all the type of expressions and statements what we have written, they are correct. This phase is carried out using the information from parse tree and the symbol table. Next comes the intermediate code generation. In this phase, the compiler translates source text into simple intermediate language. There are several possible choices for the intermediate language. We can have any intermediate language for an abstract machine. Like we are having A equal to B plus C asterisk D by F. Here we will be having intermediate code like T1 is C asterisk D. T2 is whatever result we will be getting from T1, it is divided by F. Again in T3 we will be having what? It is B plus the result that we will be getting from T2. And A, in the final A will be having the assignment from T3. So this is the intermediate code generation module. After that comes the code optimization. In this phase, the compiler tries several optimization methods. It will be replacing fragments of intermediate code text with the equivalent and faster fragments. Next is the code generation. The final phase of the compilation consists of generation of the target code from the intermediate code. When the target code corresponds to register machine, the major problem is the efficient allocation, but the fast registers to the variables, so that we can allocate the registers to the variables. Next comes the symbol table. Symbol table is what? It is a data structure. It is being used and maintained by the compiler. It consists of all the identifier names along with their data types. It helps the compiler to function smoothly by finding the identifiers quickly. So symbol table is helping your compiler to find the identifiers quickly. Error handler. The errors encountered at every phase are logged into the error handler for subsequent reporting to the user. The compiler recovers from the errors in every phase so that it can proceed with the compilation process. The compiler recovers from errors in either the panic mode of the error recovery or the freeze mode of the error recovery. We are having a multi-pass compiler also, several phases which are implemented in a single pass, that is consisting of reading of the input file and writing of the output file. The typical multi-pass compiler can do the following. It can have various passes like first pass, it will be pre-processing and macro expansion. The second pass will be syntax directed translation and IR code generation. Third pass will be optimization. And the last pass will be target machine code generation. Now we'll be seeing the example for the process of the compiler phases. The various phases we will be carrying out with the help of the example. We can see we have the previous example, position is equals to initial plus rate into 60. So lexical analyzer, what is the lexical analyzer? It was doing what? It was getting all the stream of tokens. So we'll be separating the speed of the lexical analyzer will be separating the stream of tokens. That is the first identifier ID1. Then equal to sign. Then second identifier. Then next operator that is plus. Then again the next identifier ID3. Then next operator asterisk. And the last one that is 60. Because it is a constant. We are writing it as 60. So next comes the syntax analyzer. Syntax analyzer means it will be creating a parse tree of that. Whatever we are getting from the lexical analyzer will be having fed into the parser and we'll be getting the parse tree. So here we have got the parse tree, and this parse tree will be then fed to semantic analyzer for looking into the errors, whether it is semantically correct or not. Whatever parse tree we have got, it is semantically correct or not. So here we can see all the identifiers as they are in float. We are converting this constant into float. 60 is converted into float. Then it is given to intermediate code generator. Intermediate code generator now will be developing an intermediate code. That is T1 will be first converting your 60 to float. T2 will be having the multiplication operation, and T3 will be having whatever we have got from T1 and plus T2. T1 was the int 2. We have converted 60 to float. And T2 we have got the multiplication of T1 and ID3. So T3 will be adding ID2 plus T2. And in last we'll be getting ID1 to T3. This intermediate code is then fed to code optimizer. Code optimizer means it will be reducing the number of instructions, or it will be helping to reduce your size of the program. The program size will be reduced by the code optimizer. And then this code optimizer will give the code to the code generator. Code generator, it is according to the machine language, or according to the language we are using, the code generator will generate the machine code. So here we can see the lexical analyzer, the syntax analyzer, and semantic analyzer and intermediate code generator. These four phases combinedly they are called as the front end. Front end because the coding of these four phases will be stored at a one place because they are the main part of the compiler. Suppose we want to generate a compiler for a new language. So we don't have to write the compiler from scratch. We can take lexical analyzer, syntax analyzer, semantic analyzer, and intermediate code generator portion from other compiler and just write the last two portions, that is the code optimizer and code generator. So this last two phases, code optimizer and code generator, they are combinedly called as the backend of the compiler. So hopefully these lectures would have been fruitful for you. So see you in the next series of lecture with the last two topics of Unit 1. Thank you.